Ladies and gentlemen, I am Dr. T.S. Gomti, Associate Professor, Department of Physics, Manipur University. It is of immense pleasure that I welcome you all to the inauguration of one day seminar on known as Techade-Chips for Viksit Bharat, jointly organized by the Department of Physics and Manipur Institute of Technology, Manipur University. Let us extend a warm welcome to our esteemed guests, Chief Guest Professor and Localization, Honorable Vice Chancellor, Manipur University, Guest of Honor Professor Sumitra Bhanjavan, Dean School of Mathematical and Physical Sciences, President Professor N. Basanta Singh, Dean School of Engineering, and Professor S. Basanta Kumar Sharma, Nobel Professor, Department of Physics, Manipur University. ISOBs and all distinguished personalities who grace this event with their esteemed presence. Prime Minister Narendra Modi is going to lay down foundation stone on 3 semiconductor facilities at TEPL, India's first facility at Dholera, Gujarat, TEPL Asad facility in Morigaon, Assam, and CG Power Asad facility in Sanand, Gujarat. He will address to the country at 10:30 a.m. via video conferencing to the youth of the country. India's Techade signifies India's dedication to embracing the digital age to ensure sustainable development, create new job opportunities, enhance quality of life, and establish a strong presence in the global technology landscape. On this historic moment, may I invite the guests and dignitaries, chief guests, guests of honor, president and Nobel officers onto the dais. Please, sir. Thank you, sir. Light is the symbol of enlightenment. On lighting this symbolic lamp, let us remove the darkness and provide the required enlightenment to the nearest to all of us. I now request all the dignitaries on the dais to light the lamp and symbolically inaugurate these programs. And I request our students to assist the guests in lighting the lamp. Thank you. Thank you, sir. Now I request our students to felicitate the dignitaries on the dais, Chief Guest Professor and Localization, Honorable Vice Chancellor, Manipur University, Guest of Honor, Professor Sumitra Bhanjavan, Dean School of Mathematical and Physical Sciences, President Professor N. Basanta Singh, Dean School of Engineering, and Professor S. Basanta Kumar Sharma, Nobel Officer, Department of Physics, Manipur University. Now I invite Dr. K. Associate Professor, Department of Physics, Manipur University, to deliver the welcome address. A very good morning to everyone here. It is with great pleasure and honor that I, on behalf of Department of Physics and Manipur Institute of Technology in Manipur University extends a warm welcome to each and every one of you who are assembled here for this inaugural session of one-day seminar on India's Techade-Chips for Viksit Bharat. Today marks a significant moment as we gather here to take part in India's Techade-Chips for Viksit Bharat program. At the very outset, I would like to extend my warm welcome to Professor N. Dr. Singh, Honorable Vice Chancellor, Manipur University, and chief guest of today's function. I would also like to welcome Professor Sejra Panjaban, Dean School of Mathematical and Physical Sciences, Manipur University, and guest of honor of this inaugural session. I also welcome Professor N. Basant Singh, Dean School of Engineering, Manipur University, and President of this function. I extend my warm welcome to Professor S. Basant Kumar Sharma, Nodal Officer of this one-day seminar on India's Techade-Chips for Viksit Bharat to this inaugural function. I extend my warm welcome to all the deans of various schools of the university, officers, medical officers, HODs, of various departments of the university, all the learned faculties, staffs, invitees, students, research scholars, ladies and gentlemen, who have stayed to join their valuable time to join us in this inaugural session. Thank you all for gracing us with your presence, and together let us make this one-day seminar a truly enriching journey filled with inspiration and motivation. Thank you all. Thank you, Dr. Yoda. Next, I invite Professor S. Basant Kumar Sharma, Nodal Officer, Department of Physics, Manipur University, to deliver the introductory speech.
Respected Professor Lokendra, Honorable Vice Chancellor, Manipur University, Professor Subhitra Panjabo, Dean School of Mathematical and Physical Sciences, Professor N. Basanta, Dean School of Engineering and Principal MIT, respected professors, faculty members, my dear students. So today we are conducting one-day seminar on India's Techade-Chips for Viksit Bharat. This program is related to the technology mission which has been launched by the government of India. The government of India, the ministers of the government of India through technology mission is aiming to make self-sustained electronic Bharat. So the problems that we do have, we all know that without electronics is everywhere in our day-to-day life, in our healthcare, it's everywhere. Without electronics, these days, it's very, very difficult to survive. Also that information technology is completely based on the technology advancements, internet, and with the dimension of this introduction of this artificial intelligence in many aspects of our life is becoming much more important. This electronics plays very, very important role. We all are using these electronic devices, everybody. Now our small mobile phone that we are using today, this contains millions of transistors, millions of resistors, millions of capacitors. Then how do we prepare this? Today, nobody is thinkable about in our time when we do our BSc. we start with the bulky electronic system. The television that we had then was based on cathode ray tube, CRT tube, which consumed not less than 1,200 watts. But today, the LED, which has a 55 inches LED that consume only 62 watts. And also now it's coming out that the flexible electronic devices, that this electronics, display devices also can be hung in the wall. And the Samsung has already started producing these flexible TVs. For making such advanced device, for making this highly sophisticated medical healthcare devices, we do need these electronic components in the integrated form. The world leader in producing these electronic chips, these are the United States of America, and Taiwan is also the world leader of producing this. And our India is having a lot of problems. We do assemble the devices, but we cannot manufacture the components. The main reason of this technology mission, by the year 2047, India should be able to have self-sustained resource of this components. And with this view, the government of India has started the technology mission. Therefore, the technology mission, 50% of the funding is going to be the government funding, and 50% will be the private companies. Truth is, the government of India just recently gave the cabinet approval for semiconductor plants in India. So 3 plants will be setting up. The plan number 1, that is semiconductor fab in Gujarat. The semiconductor fab in Gujarat, so the projected cost is 91,000 crores. And the capacity of this plant is 50,000 wafers per month. Why this is very important? This semiconductor wafers, with the increasing in the level of integration, the diameter of the semiconductor wafer, that is the foundation for the making these electronic devices, is steadily increasing. And the 300 millimeters, that is 1 feet diameter semiconductor wafers is going to be developed. The cost of these wafers in the market, the minimum cost is 35,000 rupees per wafer. With the event of this COVID-19 pandemic, and because of the trade war between the United States of America and China, the world is facing a lot of problem in the shortage supply of the silicon wafers. It's not able to produce enough silicon wafers for making such electronic devices. Electronic devices can be made. Once the process is standardized, these devices can be made, thousands of wafers can be processed per day. But we cannot process these silicon wafers. So silicon wafers is having a lot of demand. So with this view, this semiconductor fab in Gujarat will be run by Tata Electronics and Taiwan's Semiconductor Manufacturing Corporation of Taiwan. This Taiwanese company will give the know-how, and they will transfer this. And the background is, the focus areas for this plan is high performance compute chips with 28 nanometer technology. This 28 nanometer technology is one of the latest latest version of this technology for making these electronic devices. Power management chips in the various sectors including electric vehicles, telecoms and consumer electronics. That's the power plant number 1. We'll be setting up in Gujarat. Second, a power setup that is also by Tata Semiconductor Assembly Test Private Limited. That will be set up in Morigao, Assam. That is, the center is all-source semiconductor assembly in the place OSAT. What this OSAT will do? The devices will be manufactured in the fab in the Gujarat. After completion of this fabrication, this testing, semiconductor assembly, the testing and packaging will be done. So there will be final product that will be available in the market. Similar plan, OSAT is also again will be established in Gujarat. The Prime Minister will be laying the foundation stone of these 3 plants, semiconductor plants. And this OSAT will be controlled by Morigao Group Company CG with a partnership of Release Electronic Corporation Japan, Stars Microelectronics Thailand, and the cost outlay was 600 crores. So that's also again another assembly and the packaging plant. So what are the opportunities that we have? This plant is going to produce silicon wafers, electronic chips. So what are the opportunities that science and technology students will have? For realization of this, in our academic classes, we give the idea, we give the basic training. Then we are going to expose them to this industry. When they go to the industry, things has to be optimized and a lot of competitions is going to come up. But there's still a lot of manpower. More about some 1 lakh skill power personnel will be required for running these 3 plants. The beauty of our academic institutions and engineering institutes is give the training to our youths for making them suitable for such electronic plants. They can get employment, they can go for the job. So in this context, I will not take much more time. I'll just come directly to what the Manipur University Department of Physics is doing. What are the relevant courses that we are running in our department? In the Department of Physics, Manipur University, we are running MSc and PhD programs which are related to the scientific training of the manpowers. In the MSc, in the 3rd and the 4th semester, we do have 4 optional papers. These 4 optional papers, during their MSc, we get the basic training which is required for demand by the electronic industry. So we give them theory, we also give basic experimental techniques that can be utilized for such this. So there are material science and the advanced metaphysics, 2 papers each in the 2nd and the 3rd and the 4th semester. After completion of this MS Masters, students can undergo advanced training in materials processing, electronic materials processing, and we also do develop devices in our laboratories in the department. Altogether, 6 of us are 6 faculty members are working in the area of this material science and condensed matter physics. The protagonist are Professor Sumitra. She specializes in ferrites and multi-current materials. That is myself, Professor Vasant Kumar. I specialize in ferroelectrics, multi-ferroelectrics, semiconductor thin films, ceramics, piezoelectrics, flexible electronic devices, nanoparticles. I also got a training of this in nanotechnology in the University of Birmingham in the year 2006. Then we have Dr. Dilip Kumar Kadek's metaphysics. He has a very strong background of condensed matter theory. He also got a training from Japan. For making suitable our youths suitable for the employment in the electronic industry, both theoretical and experimental knowledge is required. So we do have Professor Philip is giving the necessary theory part, taking care of. Professor Holti is working in spectroscopy, biomaterials. Dr. Nomita Devi, semiconductor physics and photonics. Dr. Rakesh, photonics and films. His PhD from National University of Taiwan. So he also has recently joined our department. And the physics department, for the theoretical processing, we do have a high power computing facility which was procured from SAP DRS2 of the UGC project, and recently it has been upgraded from the project awarded to Professor Dilip. And also in one function, our honorable Vice Chancellor stated that our university is going to get the University Science Instrumentation Center. With the coming of this Instrumentation Center, a lot of youths will be getting very advanced training from semiconductor industry. So we can look forward for the improvement in our facility in the field of material science in the near future, and we expect that our youth will be able to compete the national competition to go through this electronic device processing. Thank you very much.
Thank you, Professor Vasant Kumar Sharma, for your very event and the speech. I now request our guest of honor, Professor Sumitra Panchava, Dean School of Mathematical and Physical Science, to deliver her speech. A very good morning to everyone present. Professor N. Lokendra Singh, Honorable Vice Chancellor, Manipur University, the chief guest of today's function, the India's one-day seminar on India's Techade-Chips for Viksit Bharat. Then Professor N. Basanta, President of today's function, Professor H. Basanta Kumar Sharma, the Nodal Officer of today's function, deans of various schools of the universities, the head of departments of the different departments of the schools, learned faculty members, officers of the university, invitees, students, research scholars, and participants of today's seminar. First of all, I would like to express my gratitude for the privilege that I have to share a few words with you on this very important and occasion of the Techade-Chips for Viksit Bharat program. So Professor Basanta has highlighted very in depth about the different projects that are to be started by the Government of India
regarding the semiconductor mission, semiconductor production, fabrication, etc. So I would like to say that this is a very important occasion and a great milestone for the country. So realizing the important role played by the semiconductor industry in a nation's journey towards technological advancement for the betterment of all sections of society, the government of India has laid a great emphasis on the development of semiconductor industry and to become independent in the production of semiconductors and their utilization in various applications. So now, with all these missions and all these efforts by the government of India, India may be able to fabricate, design and engineer semiconductor chips for various uses in our own country. So semiconductors we know have made possible the advent of integration circuitry that has totally revolutionized the electronics and the computer industries. So now these chips have widespread use in thousands of consumer and commercial products, like starting from our smartphones, computers, household appliances, the entertainment world, technological world. Name any appliance or product that gives us enjoyment, that gives us quality in our life, and a chip, semiconductor chip will be there. So this is how it is very important. The companies that manufacture them are considered as excellent indicators of the health and economy of the country. So with this project taken up by the government of India, the health and economy of the country is sure to improve. There will be job opportunities for the many youths of the country. The challenges that comes in this semiconductor chip industry is creating smaller and faster and cheaper products. So this benefit of smaller chips, as Professor Basanta has also pointed out, is that more power can be placed on the same chip. The faster, more the number, the faster and more efficient the chip can do its work. So there is fierce competition among the different companies for producing better and better chips. There is a law that I've just gone through today and saw that there is an observation called as Moore's law, which says that the number of chips that can be integrated in a semiconductor wafer is increasing day by day, and this number is doubling every 2 years. So the number that can be integrated is increasing, and the more the number, the power also increasing. So there is stiff competition in that, and it says every 2 years the number is doubled. But now with more research and with the advent of more competition, the number they say is increased in every 18 months. So every 18 months the number is projected to be increased, and so that is where our research and development comes into the picture. So these companies, they try to produce more and more of these numbers in a small chip, and that's where we can contribute as researchers. Because semiconductors, they sound very high sounding, the integrated chips, the integrated circuits, technological advancement seem very intimidating to many. But basically, what are semiconductors? They are simply materials that have electrical conductivity intermediate between insulators and conductors. This we all know from our basic sciences. And the beauty of these materials is that their properties can be enhanced, they can be manipulated, they can be tailored by putting in some impurities or dopants, we call them. So the kind of dopant, the amount of dopant, the temperature that we give, etc. So many factors can be researched upon to get better properties for these semiconductors. So that is where our university or the different universities can give our contribution in this semiconductor mission in our own small way. So I think with this mission, the country will progress towards a better quality life for all sections of the society, rich and poor, urban and rural. The gap will be reduced and we will have a very developed nation. And thank you for all these few words.
Thank you, Neelam, for your valuable and very informative speech regarding semiconductors. Unlike those our speakers, Professor and Representation, Honorable Vice Chancellor, Manipur University, to deliver the inaugural address.
Professor N. Vasanta Singh, Principal of the Manipur Institute of Technology and also Dean School of Engineering, Professor Sumitra Bhandrambam, Dean School of Physical and Mathematical Sciences, Professor Basanta Kumar Sarma, Northern Legends officer of the program and also professor of the Department of Physics, learned faculties from different departments of the universities, learned deans, academics, scientists, scholars, distinguished invitees, their students, and ladies and gentlemen. We have listened to some very interesting and very illuminating presentations given by our colleagues on the dais. And we are aware that semiconductors are essential to almost all sectors of the economy, including aerospace, automobile, communication technology, information technology, medical devices, etc. and etc. And therefore, the demand for these critical components has increased tremendously, and in fact, the demand has outstripped the supply, creating a global chip shortage and resulting in loss of jobs to a great number of our educated and skilled students and youths, and also the decline in the growth trajectory of various economies all across the globe. Semiconductors and displays are, as all of us know, are the foundation of modern electronics, driving the next phase of digital transformation under Industry 4.0. Semiconductor chips are the lifeblood of modern information age. They enable electronic products to compute and control actions, and these have considerably simplified our daily lives. These semiconductor chips are the drivers for information and communication technologies development, and one of the key reasons for the current flattening of the world. They are used in critical infrastructure such as communication, power transmission, etc. That have deeper implications for national security issues. Development of semiconductor and display ecosystem will have a multiplier effect across different sectors of the economy with deeper integration in the global value chain. They are not There are in fact many countries in the world that manufacture these chips, and these have already been pointed out by Professor Basanta. These industries are well known in some of the American and European countries, including a few of the Far Eastern economies. India currently imports chips, and the market is estimated to touch 100 billion by 2025 from the current 24 billion at present. However, for the domestic manufacturing of semiconductor chips, India has recently launched several initiatives. The Union Cabinet has allocated an amount of 76,000 crore for supporting the development of semiconductor and display manufacturing ecosystem. Consequently, a significant amount of incentives would be provided to design chips. India has also launched the scheme for promotion of manufacturing of electronic components and semiconductors, that is prospects for manufacturing of electronic components and semiconductors. In 2021, the Ministry of Electronics and Information Technology launched the Design Link Incentive, that is DLI, scheme to nurture at least 20 domestic companies involved in semiconductor design and facilitate them to achieve a turnover of more than 1,500 crore in the next 5 years. India is aiming to become the global hub for semiconductor design, manufacturing and technology development. Today, the Honorable Prime Minister of India, Shri Narendra Modi ji, will be laying foundation stones of the 3 semiconductor facilities, one at Dholera, Gujarat, the second one at Sanand, Gujarat, and the third one in Melbourne, Assam. Manipur University currently has a very competent and a very well established section of semiconductor studies in the Department of Physics. Manipur Institute of Technology has also got a separate department of electrical as well as electronics. Manipur University has produced a good number of well-trained as well as very hard-working, very competent and very well-exposed scientists and the research scholars in the area of semiconductors. In the few years from now, with the initiative taken up by the Government of India and with the manpower that Manipur University is having, so currently in the Department of Physics as well as in the Manipur Institute of Technology, we are hoping to take advantage of the expanding India's investment in the field of manufacture of semiconductors. I would like to request all our faculties in the Department of Physics who are dealing with this semiconductor studies, particularly Professor Basanta Kumar Sharma and the other faculties in Manipur Institute of Technology to give enhanced training to procure more equipments and instruments for providing better and skilled facilities to our students, so that Manipur University's students and scholars and the faculties can also take advantage of the expanding facilities in the field of the production of semiconductor chips in India. With these few words, I would like to appeal to all the members of the audience that will now be listening to After some time, the address by the Honorable Prime Minister, and after the address is over, the hall will continue to discuss on the implications of India's semiconductor mission, and all the other members will also discuss only possibilities of in what way the university can take advantage of India's semiconductor mission. With these few words, I want to thank Professor Basant Kumar for taking up this very important initiative of organizing this function. Thank you. Thank you very much.
Thank you very much, sir, for the inspiring speech. Moving on, I would like to request the President of the function, Professor Amit Basant Singh, Dean School of Engineering, to deliver the presidential address.
A very good morning to everyone present here. Honorable Vice Chancellor, Professor N. Lokendra Singh, Chief Guest of this program, Professor Sumitra Pangchondu, Dean School of Mathematical and Physical Sciences, Professor H. Vasanta Kumar Sharma, Nodal Officer of this program, respected deans of different schools, head of departments of different ICTs of different departments, officers of the university, faculties and students. Today we are gathered here to witness the foundation laying ceremony of 3 semiconductor facilities by the Honorable Prime Minister Narendra Modi ji. The first facility is in Dholera, Gujarat, and it is our migrant venture into semiconductor manufacturing facility. I mean, this is the first one in the country. And this facility will be complemented by 2 testing and assembly and testing facilities in Sanat, Gujarat and Maurera, Assam. We all know that, from the presentation given by Basanta, Sumitra, and our Honorable Vice Chancellor, now semiconductor is the driving force behind technological innovation in fields such as artificial intelligence, Internet of Things, then consumer electronics. Now, if from personal electronic device to very complex system, you will find semiconductor at the core of the system. By 2030, the global semiconductor market is expected to cross $1 trillion. And the Indian demand for semiconductor is expected to cross $110 billion. And still we do not have any facility for fabricating these chips. Currently, Taiwan is leading the race, and we can consider South Korea as the race. If you calculate in terms of time, South Korea is behind by around 6 months. And America is behind by around 2 years, if you compare to Taiwan. And we are just starting. We are starting late, but it's better late than never. Let me come to the benefits. Because previous speakers have explained about the importance of semiconductor, or Honorable Sir has expressed the various incentives of the government of India. Now, let me come to the benefits. Now, the benefits of establishing semiconductor facilities are manifold. Economically, it will attract substantial investment in the semiconductor sector, and this will lead to industrial development. Now, technologically, when there is an ecosystem, it will accelerate innovation in various sectors, and that will foster an ecosystem of cutting-edge research and development in this field. And the third thing is, with the establishment of this facility, the dependence on import for our requirement will be reduced. It is expected that within 5 years' time, the dependency of our semiconductor demand to import from Taiwan will be reduced. And the third most important thing is the employment generation. The semiconductor industry is labor inside, we require lots of labor trained manpower, and we need to create trained manpower. That is, we need to train our students. In Manipur University of Technology, the Department of Electronics and Communication is going to offer MTech course in microelectronics and real-estate design. We need to establish state-of-the-art laboratory facilities for this lecture. I would like to take this opportunity to request our Vice Chancellor to provide funds for establishment of such facilities. And in conclusion, I would like to say that the establishment of the manufacturing facilities will take a giant leap towards realizing our vision of self-reliant, technologically advanced, economically vibrant Viksit Bharat 2047. Thank you.
Thank you very much, sir, for the valuable and informative speech regarding this semiconductor. Next, we are now invite our ISOD, Professor Dilip Kumar Singh from Department of Physics to render the vote of thanks.
So good morning to everyone and all who are here today for this important occasion. So now I will take the present task of thanking one and all who have contributed to this important occasion. First of all, I would like to thank Professor N. Lokendra, Honorable VC of the University, for the full support in having this function within a very short span of 1 day. Within that day, we could, with his strong support, we could organize this function, and thanks a lot to him. I also thank the president of today's function, Professor M. Basanta, Principal, MIT, Manipur University, for agreeing to be a co-host of this important occasion. With his full support, we can see that the house is in full. That is, we have a lot of youngsters in this house. Thanks to him. I also thank our guest of honor, Dean of Mathematical and Physical Sciences, Professor Sumitra Fanjalwan, for agreeing to participate as a guest of honor at a very short notice. And I also thank Novel Officer Professor H. Basanta Kumar Sharma for having organized this event at a very short notice with a lot of effort, with a lot of, full support, because he was here till 7 p.m. yesterday night to arrange all the things here that you see on the stage and so on. Without his support, it would not have been possible to have this function at all. I also thank the deans of various schools, head of departments for gracing this important occasion, because this marks an important step for India to be self-sufficient in the technology front.
I also thank many of the staff of this university who have contributed, who have helped us till late at night yesterday to keep this hall open, to help us in every aspect. I also thank all the research scholars of the department who have contributed in preparing for this occasion with their full throttled, unthrottled efforts, because we also needed a lot of help from them to make this event happen. And I also thank everyone who are here to make this occasion a successful one. Without all your help, it would have been impossible to have this function a successful one. So I would like to end here. If I have missed anyone, I'm really sorry, because I think we are close to the time that our respected PM will start his speech. So before that, maybe we may have to have some technical arrangements, etc. So in case I have missed out anyone, I'm very, very sorry. And thank you one and all for being here to make this occasion a very successful one. Thank you.
Thank you, sir. Now I'm getting here from this closing. So now it is the time for the address delivered by the Honorable Prime Minister, Shri Narendra Modi ji, to the youth of the country, and I request the technical staff to do the needful. Thank you.
Shi xin mà, 我想一下。